Hello everyone, welcome to Science with Kawala. And in this video, we're going to look at the Avogadros number and conversion between number of moles and number of particles. So what is the Avogadros number? This is the number of particles in 1 mole of a pure substance. So how many particles are in 1 mole of any pure substance? In 1 mole of a pure substance, we have 6.02 by 10 to the power 23 particles. And this number is what we call the Avogadros number. This is what we call the Avogadros number. Okay, so what is the symbol for the Avogadros number? This is the symbol for the Avogadros number. So it's also important to understand that if I have 1 mole of any element, or 1 mole of any element has mass equivalent to its mass number. So remember, let's take an example of calcium. And this is the mass number. So if I have 1 mole of any element, the mass of 1 mole of calcium will have a mass equivalent to its mass number. So if its mass number is 40, that means the mass of 1 mole of calcium will be 40 grams. So if I have 1 mole of calcium, that means I have 6.02 by 10 to the power 23 atoms of calcium. If I get these atoms of calcium and put them on the scale should give me a reading of 40 grams. Same thing, if I have 1 mole of iron, it simply means that I have 6.02 by 10 to the power 23 atoms of iron. And what is the mass number of iron? It's 56. So that means that 1 mole of iron will also give me 56 grams. All right. The Avogadros number can also be used on subatomic particles like protons, neutrons, and electrons. So if I have 1 mole of protons, that means I have 6.02 by 10 to the power 23 protons. So now, what's the relationship between the number of moles, number of particles, and the Avogadros number? The relationship can be described into a simple formula, which is number of moles is equals to number of particles over the Avogadros number. So now, let's look at some conversions between number of moles and the number of particles. Let's look at some examples. Okay, let's look at example number 1. Example number 1 reads, how many particles are there in 2 moles of carbon atoms? What do you think? What should we do? Okay, let's try solving it. So, what information do we have and what information is missing? Data. N, number of moles, 2 moles. Then, number of particles, unknown. The Avogadros number, 6.02 by 10 to the power 23. What is the formula? Number of moles is equals to the Avogadros number, number of particles over the Avogadros number. So you can say number of moles is equals to, not number of moles. We're going to say 2 moles is equals to N, number of particles, 6.02 by 10 to the power 23. 3 atoms per mole. So when you cross multiply, you're going to have N is equals to 1.20 by 10 to the power 24. So these are the number of particles, or these are the number of atoms in 2 moles of carbon atoms. So let's look at example number 2. Example number 2 reads, how many atoms are present in 0.5 moles of oxygen gas molecules? What do you think we should do? Try solving this on your own. Okay, let's answer this. What's our data? What information do we have and what information is missing? Number of moles, 0.5 moles. Number of particles, unknown. The Avogadros number, we have 6.02 by 10 to the power 23. Okay, formula, number of moles is equal to the number of particles over the Avogadros number. Okay, so what do we need to do? What do we need to do so that we can find the number of atoms in 0.5 moles of oxygen molecules? So what we're trying to do here is first, we're trying to solve the number of molecules that are present in 0.5 moles. Once we do that, we will determine the number of atoms, because for every molecule of oxygen, there are 2 atoms. So we have 0.5 is equals to the number of particles over 6.02 by 10 to the power 23. And you cross multiply, you get the number of molecules as 3.01 by 10 to the power 23 molecules. But remember, the question is asking us to determine the number of atoms. Now, for every molecule of oxygen, there are 2 atoms. So let's imagine these are oxygen atoms, and this is 1 molecule. Another combination of 2 oxygen atoms gives us 2 molecules. So if I have 3.01 by 10 to the power 23 molecules, how many atoms do I have? What do I need to do? Yes, I need to multiply by 2. The reason is simple, it's because for every molecule, there are 2 atoms. So we're going to say 2 by 3.01 by 10 to the power 23. So what are we going to get? We're getting 6.02 by 10 to the power 23 atoms of oxygen. So these are the number of atoms present in 0.5 moles of oxygen gas molecules. All right. Now that we're done with that example, let's look at the third example. If you have 1.5 moles of sodium ions, how many individual sodium ions do you have? What do you think we can do here? Try solving this question. You can pause the video. Okay, let's solve this question. So what's our data? Number of moles is equals to 1.5 moles. Number of particles unknown. The Avogadros number, we're going to have 6.02 by 10 to the power 23 ions per mole. So the formula, number of moles is equals to number of particles over the Avogadros number. Okay, so let's write this as number of 1.5 moles is equals to capital letter N over 6.02 by 10 to the power 23 ions per mole. Okay, when you cross multiply, what are you getting? You're getting N as 9.03 by 10 to the power 23 ions. So those are the number of ions in 1.5 moles of sodium ions. Okay. Now, what about converting the number of particles to number of moles? How do we do that? Let's look at the next example. So let's look at the first example on converting the number of particles to number of moles. If you have 4.8 times 10 to the power 24 oxygen molecules, how many moles of oxygen molecules do you have? So oxygen molecules and oxygen molecules. We're not converting to atoms for this question. So what do we do? Pause the video, try solving this on your own. Okay, let's answer this question. Data, number of moles, unknown. Number of particles, we have 4.8 by 10 to the power 24 molecules. The Avogadros number, we have 4.8 by 10, we have 6.02 by 10 to the power 23 molecules per mole. Okay, so number of number of moles is equals to number of particles over the Avogadros number. So number of moles is equals to 4.8 by 10 to the power 24 molecules divided by 6.02 by 10 to the power 23 molecules per mole. All right. So now there's a common mistake that pupils tend to make with this question. When pupils are punching this on the calculator, most pupils will say 4.8 by 10 to the power 24 divided by 6.02 by 10 to the power 23. So what your calculator will do, it is that it will follow the BODMAS rule. It will start with the division first, then followed by multiplication. So this will give you a wrong answer, because if you do this, if you do not enclose this in parentheses or brackets, it's going to give you an answer such as 7.97 by 10 to the power 46, and this is very wrong. So um, be cautious when you are uh, putting these values on your calculator. So what should you do? You should enclose this in parentheses where you say 4.8 by 10 to the power 24, then divide it by 6.02 by 10 to the power 23. So when you do this, it will give you a correct answer. What answer are we getting? We're getting N as 8.0 moles. So this is how we solve this question. Let's do another example. So calculate the number of moles of helium atoms if you have 3.6 times 10 to the power 23 helium atoms. Okay. Pause this video. Try answering this question on your own. Okay. Let's answer this question. Data. Number of moles, unknown. Number of particles, we have 3.6 by 10 to the power 23 atoms. The Avogadros number, we have 6.02 by 10 to the power 23 atoms or more. What formula are we using? Number of moles is equals to the number of particles over the Avogadros number. Okay, so we're going to say number of moles is equals to 3.6 by 10 to the power 23 atoms. Put that in brackets or parentheses. Then divided by 6.02 by 10 to the power 23 atoms per mole. So number of moles is equals to, when you divide 3.6 by 10 to the power 23 over 6.02 by 10 to the power 23, you get your answer as 0.60 moles. So this is how we solve this question. Now let's look at the last example on solving questions that involve changing the number of particles into the number of moles. So let's look at example number 3. How many moles of water molecules are there in 1.2 by 10 to the power 25 water molecules? Try solving this question on your own and get back to the video. Okay, let's solve this question. Data, number of moles unknown, number of particles 1.2 by 10 to the power 25. The Avogadros number, we have 6.02 by 10 to the power 23 molecules or more. Here we have molecules. The formula, number of moles is equal to the number of particles over the Avogadros number. So we have number of moles is equals to 1.2 by 10 to the power 25 divided by 6.02 by 10 to the power 23. So molecules per mole. We'll close this in a parenthesis if you're punching this in a calculator. So number of moles will be equals to 20 moles. Number of moles will be equals to 20 moles. So we end here. Thank you very much for joining me. Please remember to like, leave a comment, subscribe, and share this video. Until next time, stay blessed.